Well, hello, AMP class. I just wanted to take a moment here to give you a few tips on a couple of things regarding how to be a little bit more successful in those online labs. And then secondly, do just a brief review for exam 4 and go over some of the commonly missed problems so you can be sure to study those in preparation for the final. Okay? All right, so first of all, we've got 3 labs left you haven't completed. One on diagnostic blood tests. That will be the week after we get back from Easter, so next week. Then the week after that, one on digestive physiology, and then the final week of class, one on urinary physiology. So let's go through a couple tips on ways to try to be a little bit more successful in those labs, okay? So, number 1 is to be thorough, okay? So that means thorough with the experiments. Okay, so very detailed, making sure that you're following the instructions carefully, making sure you're doing everything that it says, okay? And then we need to record results in tables. Okay, we give you the tables that you need in the Word document, and then they also pop up in the online lab thing. So you can get them on the online lab first, and then just copy them down into those tables, so you have them saved, and you can keep going back to those to answer more questions on those. Okay, so being thorough is very important. Okay, so it's thorough in the experiments, but we also need to be thorough in the way that we answer questions. Okay, so that means things like include units. Okay, I know sometimes, I know this could have been a little bit confusing because on the exams, I tell you not to include units because that messes up the grading of that. But in this case, this is all manually graded by the graders. So just go ahead and include units all the time. Okay. Also, don't change the units. Okay. So for example, on the respiratory physiology quiz for ventilation, some of you change the units to liters per minute, even though in the lab it reported everything in milliliters per minute. Okay, don't change it. Just report it exactly how the interactive lab shows you. Okay, so be very thorough there, including units. Don't change the units. Explain more instead of less. All right, so be more thorough in your explanation instead of just putting a short answer. Okay, you always want to just give more information, go into some of the physiology, go into some of the understanding. Okay, when it comes to the results, you want to refer specifically to your results. Okay, so don't make statements like see graph or as the data showed. No, don't make statements like that. Spell that out for us, right? So actually write in the numbers. Okay, explain the graph. Okay, so don't make any assumptions that we know what you're talking about. Okay, that's not the point of it. The point of it is for us to see that you understand it. So the more you explain it, the better. Okay, so and instead of maybe there's one that we're looking at where you have to say which condition resulted in the highest number of a certain thing. So like maybe with the ventilation one we were just doing, there could have been a patient with a normal patient versus a patient with asthma, and we say something like which condition resulted in the which one had lower inspiratory volume, right? You could just put the asthma patient. Oops, sorry, I messed that up. Asthma patient, that would probably give you half credit. Okay, what you should do instead is say the asthma patients, and spell that out, inspiratory volume, and spell that out as well, was 50. I'm just making up numbers. And the normal was 100. So asthma patient is lower, right? So that would be the more complete answer instead of just asthma patient. This should get you full credit. Okay, so explain stuff. Use complete sentences. All right. So that's some good help there. Yeah. So I think that's pretty much what I wanted to say as far as the lab goes. So now let's move down to exam 4. Okay. So in exam 4, one of the most commonly missed questions was a true and false question, true or false question that had to do with metastasis of cancer or lymphoma. Okay. Metastasis means when a tumor has spread throughout the body. Okay, lymphoma means tumor of lymph tissue. Okay, so if we find, if cancer is suspected and the lymph node is removed and they find only lymphatic tissue, then that's lymphoma, right? That tells us it's lymphoma. It tells us there's some cancer, but it doesn't tell us that cancer has spread or has metastasized because it's the tissue that's already supposed to be there, right? But if we take that lymph node and we find skin cells or bone cells, all right, or lung cells, okay, cells that aren't supposed to be there, then we say that it metastasized. Sorry, I have a hard time spelling that and talking. Metastasized. Okay, so that's the difference. If it's in the lymph node, we find tissue that is not lymphatic tissue. That means it's spread somewhere else and that's gotten picked up by the lymphatic system. Okay, second one. We had that image of an artery or an arteriole over here. Okay, and the venule over here. Okay, we had that going into a capillary bed, right? Okay, and that's going to go down. Yeah, that's a little bit more confusing than the way I had it. Let me just erase those lines in the middle. So let's just do it like this. Let's just call this our capillary, even though our capillary would really have a big capillary bed, right? It'll be a bunch of them. Let's do this to make it simpler. Okay, we had to think about, so the blood's coming in this way, right? Coming in this way, and then back out. Okay, so we need to think about both hydrostatic pressure and osmotic pressure, right? So the hydrostatic pressure is like our blood pressure, right? That's going to be highest. Hydrostatic pressure is highest on the arterial side, and HP equals lowest on the venule side, right? Because what's happening as blood is going down this direction is some fluid is leaving, right? Some fluid is leaving. So if we have less fluid in the capillary, that would mean that we're losing some fluid, right? And so then that would be less blood pressure, okay? So hydrostatic pressure, so HP is pushing out OP, osmotic pressure, is pulling in. Okay? So as the blood is traveling this direction in the capillary, hydrostatic pressure is dropping. But what about osmotic pressure? It doesn't change, right? It doesn't change because we're just losing water. So osmotic pressure doesn't change. The level of proteins and things that cause osmotic pressure don't change. But as hydrostatic pressure is dropping and osmotic pressure isn't changing, hydrostatic pressure was the dominant pressure. So HP equals dominant on the arterial side, meaning that it's higher than osmotic pressure. Okay? But then as it drops, as it goes across, at some point, that HP gets less than osmotic pressure. But that's not caused by osmotic pressure changing, that's just caused by hydrostatic pressure dropping. So the question was, under normal/healthy conditions inside the blood vessel, at C, which was the venule side, osmotic pressure is the dominant pressure. Okay, and that was true or false, which most of you said it was. Yes, that was true. And then, but 52% of you said osmotic pressure at the arterial side is higher than the venule side. And you said that was because the osmotic pressure, yeah, right there, because osmotic pressure is higher on the venule side than it is at the arterial side. But that would imply that osmotic pressure changes. Okay, osmotic pressure doesn't change. It's just the hydrostatic pressure goes lower than osmotic pressure, and that's why. So osmotic pressure equals dominant on the venule side. So at that point, fluid can come back in. Okay, so fluid can come back in. Osmotic pressure is the dominant pressure on the venule side because HP dropped. That's the only reason, not because osmotic pressure changed. Okay, moving on. Just a couple more. You guys did very well on this exam, by the way. Average score of an 81, which is very good. Complex information on the immune system and the lymphatic system for sure. So, other one, when you give someone the wrong blood in a transfusion, what happens? This was in that hybrid question. There were a bunch of options there. Many of you only about half of you got this one right. So, the donor's blood, donor is giving red blood cells with antigens. No antibodies are given. Okay? No antibodies, we give red blood cell with antigen. The recipient what we have to worry about with the recipient is the antibodies in the recipient's blood. Okay, so let's say we give the wrong blood to the recipient. If we give the wrong blood, what happens is the recipient's antibodies stick to the antigens on the donor's blood. All right, so there are a bunch of different variations of that sentence as options on the exam, and a lot of you just got mixed up with the words, but that's what would happen. The recipient's antibodies stick to the antigens on the donor's blood. Okay? All right. A couple other things. I've said this multiple times in class, trying to make sure everybody got it, but it's always something that's easily missed. So, B cells and T cells are the lymphocytes. Okay, those are lymphocytes. And they're both part of the adaptive immune system. Okay, T cells carry out the cellular immunity, and B cells carry out humoral immunity. Okay? When we activate a B cell, it now turns into a plasma cell. That means it goes out into the blood, starts releasing its weapons, right? So what are the weapons? These are the antibodies. Okay? T cells are the cellular immunity side. The weapon form of those, the ones that actually do the killing, weapons are the cytotoxic T cells. Okay? And so that's a key thing to understand, that breakdown and that hierarchy. Okay? Some of you missed some of those around or in that big hybrid question at the end. Okay, and then 3 definitions that people struggle with a bit. Agglutination and precipitation. Okay, think of agglutination as sticking together large things like cells, bacteria, larger things, right? And then that pretty much immobilizes them, gets them stuck in places. Okay, precipitation is sticking together small things, and then what that does is that pulls them out of solution. Okay, and then so those are both actions of antibodies. Right, this is all part of the plano thing. And then lastly, opsonization equals marking infected cells for phagocytosis. Okay, so that antibody sticks to the outside of that cell. That little stick that the antibody stuck in there, that attracts macrophages and other immune cells, and then the macrophages come and destroy those. Okay, so those are some of the most commonly missed things on the on exam 4. So hopefully this is helpful. Please let me know if you have any questions. All right, guys, have a wonderful Easter. Hope you enjoy some time with your family, and hope you get to celebrate the resurrection of Christ in some way, as we're all stuck inside, kind of quarantined, but hopefully we can enjoy some time with some people that we love. All right, guys, have a wonderful time. I'll be back in touch with you probably on Tuesday or Wednesday next week.